in this video, I'm going to go through section 2.4, which is finding areas within a normal distribution. So the first thing that I want to talk about was the z-table. So we're using the z-table and the z-score formula to calculate some percentages. So when you are doing problems on Edgenuity, it always does this as a pop-up. If you have a printer, I would suggest maybe printing it out so that you have it as a hard copy to look at instead of having to always pull that pop-up and look at the percentages on there. So again, that's my suggestion. Remember that there's two parts to it. So the first one is the probability of the z-scores that are negative, so they're below the mean, and then the z-scores that are positive, they're above the mean. And so this table gives you the percentage below that z-score. Remember that one of the topics in here is that if it's at the z-score, it doesn't add anything to that percentage. So whether it's less than or equal to, you'll still have the same answer for your percentages. And so I have just a couple examples just to go through, because there was a lot of information on this video. And so remember that the formula for a z-score, and I'm just going to use the symbols, is that the z-score is equal to the x value minus the mean divided by the standard deviation. And so we're looking for those three pieces in order to calculate a z-score and then answer the question. So in this first problem, we have the heights of 8-year-old girls in a large school district. They're normally distributed with a mean of 50 inches. So mean is the mu. So our mu is 50 inches and a standard deviation of 2.5 inches. So sigma is 2.5. What percent of 8-year-old girls in the school district are shorter than Ava, who is 53 inches tall? So that's our x value. So to do this, we need to first find Ava's z-score. So Ava's z-score is going to be found by taking her height, which is 53 inches, subtracting that mean of 50 inches, and then dividing by the z-score of 2.5. Okay, so we're going to do 53 minus 50. So we're going to take 3 and divide that by 2.5. And so that gives us a z-score of 1.2. Okay, so that means that Ava's height is 1.2 standard deviations above the mean. And remember that when we're looking for percentages, we always want two values after the decimal. So that's how our table works. So we're looking for 1.2 and then the 0 across the top. Okay, so I'm looking for a positive z-score. So I'm going to look at this table here. I'm going to zoom in. So I can see the 1.2. Switch back. So the 1.2 row is here. And then the column that represents 0 is here. So I'm looking at where those two pieces meet, and that's going to give me my percentage. So that means that 0.8849 or 88.49% of those girls are shorter than Ava. So this number gives us 0.8849. And again, that's the area under the curve if she is at 1.2 standard deviations above the mean. That's giving us this area. And so we want to double check, does that represent people shorter than Ava? And that's true. So that means that our answer is just 88.49%. Okay, so we calculate the z-score, then we use the z-table and ensure that that value is representing the question. So if it's less than her height, shorter than her height, then we just use the value. If it's something different, we have to do a little bit of calculations. So the next question, we're talking about boys now. And so we're going to find the z-score of a boy. And so the heights of 12-year-old boys this time in the large school district are normally distributed with a mean, so a mu, not a sigma, of 61 inches. So we've got 61 that we're subtracting from the height that we're given. And a standard deviation of also 2.5 inches. So sigma is 2.5. So that's our denominator. They want to know what percent of 12-year-old boys in the district are taller than Logan, who is 57 inches tall. So if we think about what this means in terms of taller, that means that when I find my distribution, I'm going to shade to the right, because that's where values are larger, which would represent who is taller. So let's find Logan's z-score and then see where he lies on this normal distribution. So 57 minus 61 is going to give us -4. We're going to divide that by 2.5. And that gives us a z-score of -1.6. So I'm going to look up on my z-table -1.6 in the rows, and then that double 0 in the column. Okay, so I'm looking for -1.6. On the other z-table, and then we're at 0, -1.60, so I'm looking at that first column to figure out where those two things meet. So that's going to give me a percentage, an area under the curve of 0.548. Okay, so this gives me 0.548. Did I write that right? No, I put the 0 in the wrong spot. Sorry. 0.0548. And so remember that the way that the table works is, so if I have a -1.6, I'm somewhere between -1 and -2. So if this is -1.6, this percentage is given here. So this is 5.48%. However, that's not what I want to know. So I need to know what the percentage is to the right. So I'm looking for this area over here instead. And so remember that in the video he talked about, I'm just going to either subtract this value from 1, the decimal value from 1, or I'm going to subtract the percent value from 100. Okay, so whichever way you're doing that, I'm just going to do the 100. So if I do 100 minus 5.48, that's going to give me the percentage of the area above Logan's height, so people that are taller than Logan. One hint that he gives in the following video, and I just want to show you now, is that based on the symmetry of the normal distribution, what happens is that if I look at instead positive 1.6, so if I'm looking at positive 1.6, and if I look that up on the z-table, I'll actually get this same percentage. Okay, so if I look at positive 1.6, look at that, I get 9.9452, right? 0.9452, 94.52%. So one strategy, instead of having to subtract from 100, is if I'm looking for something that's shaded to the right instead of shaded to the left, I can look at the opposite z-score. And then I don't have to subtract from 100. So to skip that step of having to subtract from 100, I can look up the opposite z-score. So since this z-score was negative, I looked up the positive. So for example, if I wanted to go back and find the people that are taller than Ava, since her z-score was positive 1.2, I would look up negative 1.2, and that would tell me that 11.51% of the girls are taller than Ava, okay? And I would get that same value if I did this 88% minus 100. Okay, so that's just a shortcut. He'll talk about it in the next lesson. So if you want to use it, then you can. The final one is a between. So with the between, we have to find both z-scores and subtract. So all students who complete the Math 3 course at Ridgeway High School take a common final exam. So these scores are normally distributed with a mean of 105, so that's our mu, and a standard deviation of 16. Kyle and Ethan are Math 3 students who took the exam. So Kyle's score was 135. So for Kyle, we're going to take 135 minus the mean divided by standard deviation. Ethan's was 93. So for his score, we're going to do 93 minus the mean divided by the standard deviation. What percent of students who took the exam received scores that fell between Ethan and Kyle's scores? So when we're thinking about this normal distribution, we want to find each of their z-scores and find the area between those two values. So if the mean is 105 and the standard deviation is 16, we're going to divide 30 by 16. And that gives us a z-score of approximately 1.88. So notice that that should have given you 1.875, but a z-score table only has 2 decimal values, so we want to round up to the nearest 100. For Ethan, we're going to do 93 minus 105, so we're going to have a negative 12 divided by a positive 16, and that one's going to give us exactly 0.75. Okay, so Ethan's z-score is 0.75. So if I think about the standard normal table, distribution, sorry, I'm going to draw Kyle's line here. So 1.88 would be over here kind of close to 2. And Ethan's 0.75 would be over here. Sorry, that was negative 0.75. Negative 0.75 would be over here. And so we're looking for this area between the values. And so remember that what we're going to do is look up the 2 separate percentages, the 2 separate areas under the curve, and subtract them to find the area between. So if I find Ethan's, right, if I look up the percentage below here, so I'm looking at negative 0.75. So negative 0.7 is here. And then 5 is this one. Didn't change colors. 5 is this one. So that's going to give me 0.2266 or 22.66%. And then I'm going to look up Kyle's score, 1.88. So I'm looking at the positive z-table this time. So 1.8 is here. And then 0.8 is here. So I'm looking at where those two meet, which is 0.9699, so 96.99%. And so if I want to find between, I'm going to subtract those two values. So if I subtract 96.99 minus 22.66, that's going to give us 74.33%. Okay, so that means that 74.33% of students that took that exam had a score between Ethan and Kyle's scores.